Okay, folks, hello. My name is Matt Ellis. Thank you all for coming. I'm here to talk about the Clippy for Resharper plugin. We're going to have a look at, we're going to pull it apart a bit and have a look at some of the more interesting things about it. As a bit of an introduction, it was really kind of just an April Fool's joke, which has gone down surprisingly well. We've had rather a few people actually using it for real, which is definitely a surprise for me. The idea was, it's an obvious one. Have Clippy, the venerated Office assistant, would help you with all your refactorings and everything, and it looks great in the screenshots and everything. But the punchline to the joke is that it's actually a real plugin, that it really works. It helps you. It takes over Alt-Enter and so on, and it helps you to work. But the interesting thing really here is that it's not your usual extension. It doesn't use any of the standard extension points. It doesn't look at the source code or syntax tree. It doesn't provide any analyses. It doesn't provide any refactorings. Doesn't provide any standard UI commands. Doesn't hook into the menus. Doesn't add anything to Alt-Enter or anything. So it's going to be interesting from this point of view because it doesn't use any of the standard extension points. But it still is an extension. It's still a real extension. It has the same structure as a traditional plugin. So we can have a look at that. It has the same concerns as traditional plugin. So it's going to be interesting to have a look at some of these slightly more low level, slightly more, I guess, day-to-day points which all plugins have to look at. So we're going to have a quick look at some components, how components work, how lifetime management works, some threading issues, and some data flow. And if we've got time, we'll have a quick look at some versioning and setting stuff. Now, just as a reminder, this is what Clippy itself does. When you open up a solution, load up a solution, there it goes. He appears up down the bottom here, ready to help. If you click him, he provides a list of options for you to do, and those options actually work. He takes over the Alt-Enter menu so that you can have your refactor menus, so you can change the signature, and it pops up your standard refactoring dialogues. You can Alt-Enter here, and the Alt-Enter is taken over by Clippy. It appears there. You can use the keyboard, scroll through, hit, and keep on working with him. It'll also jump in and take over some of the in-place refactorings. So if we rename that, we've got the dotted outline here to indicate that we're an in-place refactoring. And we get here to say, we can apply the rename refactoring or just edit the code and carry on. And if we click that, it applies it, and the refactoring is reflected everywhere else. It also takes over some of the other shortcuts. So for example, if we want to refactor this, it pops up here. If we want to go to and navigate, again, it pops up and it takes control over those. So what we're going to do now, though, is take a quick look at the solution. So if we switch to the solution here, it's available on GitHub. You can download it. It's on my account, github.com/citizenmatt. The repo name is Resharper-Clippy. And the solution here, it's got three main projects in it. It's got a version for Resharper 8.1, a version for Resharper 8.2, so they're both packaged together, and anybody using 8.1, anybody using 8.2 can benefit, can use it. And it's also got a test harness project. The test harness project is just a simple application which will give me a window which will allow me to run the application, to run Clippy, and to try and show the balloon and to hide all the options and everything. And you click it, and you can see that it's working. But the fun stuff actually happens in the main solution. So if we have a look inside here, we get to see that there's a source folder, and inside there we kind of got things split into two. We've got the agent API. This is all the actual code to talk to Clippy and to make Clippy animate and appear and show the balloons and so on. And then we've got all of these handlers down here, which are the implementation, the client side, the hooking into Resharper and getting Clippy to do what it does. So we'll have a quick look at the agent API first of all. The way Clippy works is by using a third-party component to do it. It's a component called Double Agent, which is an open-source implementation of Microsoft's Agent API. It's also a COM component, which is great if you've got it installed. It's a little bit tricky if you don't have it installed, and so we have to do some side-by-side magic using an activation context in order to load up a COM object, which is just not registered on the computer, but is sitting in a DLL side by side with your component. This is all fun and interesting, lots of p-invoke, and we're not going to look too far into that. If you want to look any deeper, there's a blog post here which provides a lot of information, but it involves using some p-invoke and loading up a .manifest file which says if anybody tries to load this COM object, it lives in this dacontrol.dll file, which is distributed side by side with the current executable. Okay, so the main entry point for the API for when we're using it is the agent manager class. What we can see here is that this is responsible for actually loading the COM object. And the first thing it does, it uses the activation context, uses the pinvoke methods to load up our file and then to call new control. The control is actually a class which lives in the double agent namespace and is our main entry point to the COM object. We set some flags, we set the search path, wire up some events, and we've got a whole bunch of event handlers then, which are kind of boilerplate and not terribly interesting. The next interesting method we've got, public method, is getAgent. If we pass in the character name, it's going to be Clippy, and this is then the method which will call load on the character, get a hold of the character itself, pass in some settings, and again we'll look at some settings if we get some time towards the end, to set whether sound effects are enabled or not, and then we wrap the characters that's returned back in another class which provides a slightly more easy to use API, and that's what gets returned then to be used. If we look at agent character, we can see that there's a whole bunch of stuff going on. We've got a whole bunch of methods, so if we have a look at our public methods, we've got play for playing animation, we can move to, we've got events for when it's clicked, we can hide it, we can stop animations, we can show, and so on. The other thing that this class maintains is the balloon itself. So the balloon that gets displayed sadly can't come from the double agent API, because the balloon which the Microsoft agent supports is a simple text balloon, whereas we want something which looks a bit more like the balloon which the Office agents used, which had the items which you could select, the links you could select, and buttons and so on. And so this is all handled by a balloon manager class. I'm going to have a look at this in a little bit more detail later, but what it effectively does is create a new balloon window. And over on the right here, we've got a whole bunch of files which are all about building the balloon. The balloon itself is a WPF control which lives inside a Windows Forms host. The Windows Forms host is responsible for drawing the outline of the balloon with a little tail sticking out, and the WPF control is responsible for the text, the wrapping, the list of items, and the handling of all the clicking. Again, this isn't terribly interesting. It's standard WPF with dependency properties, and just making sure that we're displaying the right list, the page of items at the same time, and the next buttons and so on. The same with the Windows Forms, the Windows Forms host window. We've got a whole lot of boilerplates. Where are we? A whole lot of boilerplates, GDI plus system drawing of figures and so on. If you want to have a look, you can grab the solution and have a look and dive into that. So once we've got our agent character, we then have we then got one final facade, which is our main API here, this agent class here. If we have a look, we've now got a much simpler API where we get to show, hide, and play animations. We can also then show a balloon, and we've got ways of checking when the agent itself was clicked, when the buttons, any of the buttons in the balloon were clicked, or any of the options in the balloon itself were clicked. So what we can also see here is that we have got this is where we initialize it. So yeah, so when this class is instantiated, we set up a lazy object here, which will hold our value of the agent character. So it provides lazy initialization of the agent character. It takes in the agent manager, it initializes it, gets the agent with Clippy, formal name Clippit, and we wire up our events and load it all up there. So when we're ready to actually use it, we have the agent character exposed here, and every time we want to do something, such as moving it and showing it, we've got a wrapper method which will make sure that everything is loaded just in time in a lazy fashion. And that's a very, very quick, very broad overview of how we talk to the agent, because the interesting stuff is actually outside of the agent and using the agent itself. So, Robert, do we have any questions so far on the agent itself?
Hi, Matt. Can you hear me okay?
Yep, sure.
Yeah, so first we had a couple questions. The first one, Robert asked if we can link the source code from the blog when we publish this, and I don't think there's a problem in doing that, right?
No, that's no problem.
Okay, so we'll be sure to do that. And the question would be, why is Agent using a JetBrains lazy class instead of the built-in system one?
Right, yeah, that's this this here. The short answer really is for compatibility. The lazy object for the system class is a .NET 4 object, and Resharper plugins are .NET 3.5. They can be from .NET 3.5 onwards, so they can support Visual Studio 2008 and onwards. As it happens, this particular this particular plugin is a .NET 4 application, so it doesn't really matter. However, the there are certain APIs in Resharper which expect a lazy, and they do expect a JetBrains lazy rather than a system.NET lazy, because not all of the classes in Resharper are .NET 4 assemblies.
Okay, thank you. The other questions I think we can handle by ourselves. So if you want to continue, we'll collect questions for the next break.
Okay, sure.
Thanks.
Okay, then. So extension points. I kind of said it wasn't using any of the standard extension points. It does use a couple of extension points which are interesting, however. The first one is the alt enter handler. So the way we get to override alt enter is by using this alt enter handler interface. This allows us to this will be called for anytime the alt enter itself is used. It has just a couple of methods: is available and handle the action. And is available allows us to say that it checks a data context, which is the context of the solution at the moment, whether any text is selected, whether there are any text controls available, and so on. And you get to say whether or not you can handle the alt enter in this particular instance. Handle action is when you actually get to handle it, and you can return true or false. If you return false, it's saying that this particular implementation of alt enter handler doesn't handle it. Now, Resharper has a few of these handlers already built in. They're mostly there for displaying the indicator from the pop-up from the icon on the left-hand side of the screen here, either in the gutter or where it appears floating. There's also an implementation which will make sure that any code completion windows have been hidden before displaying the alt enter pop-up itself. And there's another interesting one, which is the center F# alt enter handler. This has just made my screen go very blank. This particular implementation will, there we go. This particular implementation is because Resharper takes over the alt enter keyboard shortcut. That's a well-known keyboard shortcut for the F# tools, and what this allows us to do is keep alt enter for Resharper and also have it for F# as well. It has a priority of int max value, so it's the highest possible priority, which means that it's going to get handled last. Resharper maintains a chain of these alt enter handler implementations in lowest to highest value of priority, and it'll implement the lowest ones first. If nobody previously in the chain handles it, we then call through to the F# implementation. The implementation in Clippy is a whole lot easier. We say that we're always available. To handle the action, we go off and we get any bulb items, any these items in the list, in these lists here. Any of these items, they're described as bulb items. We get to see if we got any. If there aren't any, we return false and we carry on. Otherwise, we build a balloon options for it, do some wiring up here, and eventually we call agent show balloon. And that's basically how we override the alt enter handler. The other interesting extension point we use is by overriding some actions. Resharper allows you to build to create action handlers. So if you create a plugin from the templates that ship with the SDK, you get a couple of action handlers implemented by default. These, as examples, these action handlers can then be tied to an action itself, and an action can be a command in a menu item. It can be in a drop-down menu item, or appear in context menus, or as toolbars in tool windows. But then this separation then allows us to keep things nice and clean. Allows us to have the action implemented in lots of different places, but only have one handler. But as part of that, we can also register multiple handlers. So we've got an action manager here. We get an executable for a particular, sorry, we get an action for a particular action ID, such as go to recent edits or go to recent files, and then we add a new handler to it. Resharper itself uses this in situations such as expanding live templates, and when it wants to override the tab key to tab between all the different hotspots in a live template. It can add in it can call add handler on the tab action and implement that for hotspots, and then remove the handler when the live template session has completed. What we do here is we just register a whole bunch of new handlers for a whole bunch of different actions themselves, and we create new actions which actually implement it. These actions are implemented in this overridden actions folder here. I'm not going to go into these too much because things start to get a little bit hairy here. The problem here is that to get this working with Clippy, I needed to override some behavior which was several base classes removed from these actions. So the code's not terribly nasty, but it's a little bit messy. And it's not necessary to go through right now, but it boils down to calling again agent show balloon. We get a list of items to display, and we show a cancel button, and we show the balloon, and we carry on from there. There is an easy way, of course, of override of where are we? That's the one. There is an easy way of overriding handlers. So if you want to take advantage of this and override an existing handler, you can actually implement your action handler by deriving from the overriding action handler here, and you call down into the base class, pass in the list of action IDs that you want to override, and then that will actually override those and implement it for you. Okay, so that's what I want to talk about with extension points. Robert, any more questions right now?
Yes, there is, Matt. How do you know the names of the actions to override?
Okay, that's a little bit tricky, unfortunately. The names of the actions are implemented in Resharper, and there's a couple of ways you can do it. So, for example, we can use the refactor this action. If we find the one from Resharper itself, the action can be the action ID can be defined as a string parameter to the action handler attribute on the action handler itself. You can also find it implemented inside the actions.xml files, which are embedded as resources in assemblies. This is not the nicest way of doing it, unfortunately. So the best thing to do is to look in .peek, try and find the action handler which corresponds to it. They are usually named very much like as you'd expect, and you either get it from the action handler as a string, or it will be based on a naming convention. So if the class doesn't have the action handler attribute on it, but its name ends in action, the action ID is the start of the name preceding the action. So in this case, it would be refactor this. Is that okay, Robert?
That's wonderful, Matt. Go ahead, please continue.
Okay, so the next thing I wanted to look at then is how some of these objects get created. It's a concern which all plugins have, and all plugins need to implement, need to understand, and it's how to work with Resharper's component model. Resharper comes with a built-in component container for an IOC component, an IOC container for creating objects, for handling dependencies, and for injecting dependencies into objects. It has several scopes. It has several nested scopes of that. It has a shell scope which manages the lifetime of objects for the entire lifetime of Visual Studio. It has some which are scoped to solution level, and it can even scope you down to project level as well. If we have a look at the agent object, for example, we can see that we have got the shell component attribute on this class. This means that the object is created when Resharper first starts up, and it stays alive until Resharper is closed down, when Visual Studio itself is closed down. If we then hop back to, let's have a look, overriding action registrar, we can see this one's actually a solution component because our actions have solution scope. And this means that this object will get created when the solution is opened, and it will go out of scope and get garbage collected when the solution itself is closed. A better example would be our solution visibility scope class. This class is responsible for, if we pop back to Clippy, so if we close down this solution, we see that Clippy animates away and disappears. And if we open it back up, when the solution opens, Clippy animates in and is available. That's what this class does. This class is a solution component. It takes agent in as dependency. So when Resharper is opening the solution, it looks for any classes which are marked with solution components. It'll create an instance of this. It'll ensure that agent is created beforehand. We already know that because it's a shell component. It'll pass it through to the constructor of this, and then we immediately call agent.show, passing in true to make it do the nice animation. Because this class also implements iDisposable, when the solution is closed, Resharper will make sure that dispose is called. And when dispose is called, it just calls agent.hide. And so we've got a very simple way here of doing something, of making sure that an action happens when the solution is opened, and when it happens when a solution is closed. The other really important thing I want to point out here is that given something like the alt-enter handler, this is one of Resharper's interfaces. This is Resharper saying, here's an extension point. This is something you can implement, and I will add it to my list of other alt-enter handlers. That has to also be a component. It has to be created by Resharper itself so that the Resharper can find it, can know about it, can add it to its list of things. And that's kind of obvious. But one thing that perhaps is less obvious is when you have a class which doesn't implement any of those interfaces, that's not used directly by Resharper. These can be components too. So you can create your own classes to be components. So the component architecture, the component's infrastructure is not just for Resharper's extensibility, for Resharper's classes. It's a general purpose IOC container for creating objects, managing lifetime, managing dependencies. So that's the kind of the key thing I wanted to point out here, is that you get to use it for your own objects as well as just for extension points for Resharper itself. And Robert, any other questions about components?
Yes. What is the order of component creation?
Right. So Resharper will ensure that okay, so yes, Resharper will ensure that any dependencies are satisfied before it creates your class. So for example, the agent click handler, so this is the class which handles the click events on Clippy itself. It takes in a whole bunch of dependencies here. It ensures that these are all created and all exist before instantiating your class, before instantiating this class. There is a way of decoupling that a little bit. Let's see. Highlighting tracker, that would be it. So for example, this is a solution component. It takes in a bunch of dependencies here. This last one is an iViewable. iViewable is a class which is interface which is very similar to Reactive Extension's iObservable, in that it is a a push-based observable collection. So you have a view method here. You pass in an action with a viewer. We'll come back to the lifetime in a minute. You pass in an action which is a viewer, and every time a new value comes into a collection, your viewer callback is notified here, and he can be called. But the interesting thing with this though is because it's a push-based notification, that means that you can have that these highlighting change handler instances can come in at any time. So Resharper can use this. A great example of where Resharper uses this is with extensions itself. An extension can be live loaded. So if you install an extension in the middle of a Resharper session, it's immediately loaded and added into the component object model. And Resharper will satisfy any of these iViewable. So if your plugin implemented iHighlighting change handler, then my this class would get notified that a new value is available. And so you've got a way there of decoupling from the order of creation, and have creation be notified when new values are available. That's what I'm trying to say. Okay.
Okay, thank you, Matt. We'll answer the other questions so we can stay on track.
Okay, good stuff. Right then, so the next thing we want to look at, where are we? So let's have a look at, if we go back to our agent class here, and in fact, most of the classes we've looked at so far have taken in this lifetime parameter as part of their constructor. This is a very powerful mechanism for code cleanup. It's well, we can see where it's being used here. That the agent itself is calling add action, and it's passing then through a callback, which immediately calls agent manager.unload action. Unload agent, and passes the character back in. What this does is it registers a callback with the lifetime, and the lifetime is an object which represents, funnily enough, the whole lifetime of the object. And when the lifetime itself terminates, it calls all of these actions to do cleanup. So you can kind of think of it as the inverse or the jeweler of iDisposable. Whereas when you're doing code cleanup with iDisposable, you return an object back which knows how to do code cleanup when the lifetime is finished. What happens here is you are passed an object which represents the lifetime, and you can then register callbacks to do cleanup with it. So iDisposable itself is great for managing resources, especially for managing for handling unmanaged resources. When you say have a bitmap that is allocating unmanaged resources, and then you want to use it, you want to manipulate it, and then you want to destroy it, and you want to have deterministic cleanup of those unmanaged resources. So it's great to use in those small scopes where you get a resource, you use it, and then you destroy it. It's not so good for organizing, managing cleanup when the scope is wider, because it then sort of becomes an object, an exercise in bookkeeping, especially when you're dealing with a lot of objects that need cleanup. The caller then has to maintain a whole list of disposables and has to dispose them in the right order and with the right semantics, and lifetime takes care of all this for you. So what happens here is that the solution component, the component model, creates the agent and it gives it a lifetime. The lifetime is, because it's a shell component, the lifetime is scoped to the lifetime of the shell, of lifetime of Resharper itself. The agent then adds an action so that when the lifetime is terminated, when the Resharper itself is terminated, it will call this callback, and that callback will unload the agent and clean up all of those resources. A good example here is when we have a look at the build animations. So when we are doing a build with Clippy, what we do is we subscribe to the build notifications and we play animation. Let's see if we can just demonstrate. Is this going to be too quick? It's too quick. We get the save animation instead. Okay. Um, so what we get here though is we have a solution component. It takes in a lifetime. It also takes in the agent. The lifetime is now scoped to the solution. So when the solution closes, the lifetime itself is destroyed. And we call subscribe events. We get the DTE, the DT events, DT build events, and we call lifetime.add bracket, and we pass in two functions. The first function subscribes to the onBuild begin event. The second function unsubscribes from it. When you call add bracket, the first function is called immediately, and the second function is called when the lifetime itself terminates. So this event will be subscribed to for the whole duration of the solution. When the solution is closed, this callback will get called, and the events are unsubscribed. Let's have a look. So if we have a look at the sort of the shape of the lifetime class itself, we've got several methods. We've got add dispose, where you get to add a disposable object, and this is kind of almost like a bridge then between the disposable and the lifetime worlds. We can pass in the disposable object. When the lifetime terminates, it will call item.dispose. We can pass in an action. When the lifetime terminates, it calls the action. Simply as that. When we can have a bracket, the F opening parameter here, the F opening action, is immediately called. When the lifetime terminates, the F closing item action is called. And we've also got an add ref method. This allows you to keep an object around but not have to do any cleanup with it, but it keeps it around for the lifetime of the lifetime object. So it's like calling gc.keepAlive on that particular object. There are also lots of very useful extension methods. For example, on collection, there are extension methods for the add method. So you can add an item in with a lifetime. When the lifetime is terminated, a callback removes the item from the collection, and it can do the same with a range. Okay, so how do you create a lifetime? The easiest way is to not have to create it and get one passed into you on the constructor of the component model. But if you do need to, you can use the lifetimes class to create one. You can have a tightly scoped lifetime with the using method. These are static methods. You just call using, you pass in the action. The action takes in the newly created lifetime. You do some work with it. When your action finishes, the lifetime is terminated. Any callbacks that are registered are called, and they get removed. The usual way you'd call it is by using define. Define takes in a parent lifetime. It also takes in an ID for debugging purposes, and the F atomic method is called immediately, passing in the newly created definition of a lifetime. This returns back a lifetime definition object, which you can see at the bottom of the screen. That just has a simple method called terminate, which will terminate the lifetime itself, and that means that any callbacks registered will get run. You also got a flag to see whether or not it's been terminated and access to the lifetime itself. The definition and the instance of the lifetime are kept separate, so that when you pass in a lifetime to a child object, that child object cannot terminate that lifetime by mistake and make a mess of everything. There are a couple of other methods called create intersection 2 as it happens, and synchronize. The create intersection one I'll come back to in a sec. The synchronize one is it takes in a number of definitions, and it will tie those definitions together. When one definition terminates, all the other definitions that are passed in will also terminate. Just going back to the define, it's worth pointing out when you've got a parent definition, you pass in a parent lifetime, and when that parent itself terminates, then this child lifetime will also terminate. So lifetimes are scoped in this manner. Okay, which if we pop back to solution visibility scope, we see now that we could actually rewrite this using lifetime. So if we take in a lifetime here, we could add a bracket, one that will pass in a method that's going to get called when we first create it, and we pass in a method that gets called when the lifetime terminates. And now we don't need any more of that. and we don't need an implementation of dispose now. We can handle everything using a lifetime. So a very powerful mechanism for doing code cleanup and for scoping actions for within a particular period of time. Okay, so we can take things a little bit further with lifetimes as well. They're very powerful mechanisms as they stand, but then there are times when we want to do something a little bit more interesting, and we've got means of handling this without adding any more bookkeeping on top of this. So if we have a look at the build animations class, this runs an animation for the duration of the build, as I said. And if we've got our subscriptions going on here, and these methods called onBuild begin and onBuild done. Now, when onBuild begin happens, we want to start running an animation. This is a repeating animation. As far as the agent is concerned, it will just keep on playing it until it is told to stop. One nice way of doing it is by passing in a lifetime. We could pass in a lifetime. When that lifetime gets terminated, the animation will stop. So we don't have to now explicitly manage keeping track of all of this. We reduce our housekeeping here. And we've got a way of doing sorry. The other thing we have here is that given we have these two events live in pairs. We've got a begin event and we've got a done event. If these get called out of sync, we don't want to have to be managing that in our housekeeping to say, okay, well, on build begin, I've got to make sure that the last set of animations was terminated before starting a new set of animations. And in on build done, I don't want to be having to check to see whether there's a current animation in order to terminate it. So what we can do is we can use a class called Sequential Lifetimes, which Resharper provides to manage this for us. The sequential lifetime is designed to allow a single action to happen at a time. When you call next, it will terminate the current lifetime, create a new one, and pass that to the callback. So if the build starts multiple times, it will terminate the current lifetime, which stops the current animation. Then it will create a new lifetime, pass it to our callback, which we then pass to agent.play, and we use that to start a new animation. When we're ready to stop the animation, we just call terminate current, and the sequential lifetimes class is responsible for doing the housekeeping to check whether there's something running there or not. To make this a little bit more obvious what's going on, we've got a diagram here. So here's our sequential lifetimes class. We've got a constructor, we give it a parent lifetime. We've got a next and a define next method. The only difference between the two is that define next also passes in the lifetime definition that's just been created, as well as the lifetime that's just been created. And it's also got a terminate current method, which will terminate the current method. So if we look at what we have here, we've got a parent lifetime living across the top there. When we call next, we create a child lifetime, and we can close that child lifetime. We can terminate that by just calling terminate current. We can then create a new child lifetime by calling next or define next again. And then if we call next or define next, that will terminate again, that terminates the child lifetime and creates a new one. And then finally, the child lifetime itself is bound to the parent lifetime. So when the parent terminates, the child terminates itself. So again, we've got a very powerful mechanism for stopping and starting operations without having to maintain a whole lot of housekeeping going on. We do the same sort of thing in our balloon manager class. So when we call create new to display a new balloon, we pass in a client lifetime. Here, this is the lifetime that we want the balloon to have. We've got a balloon lifetimes here, which is a sequential lifetime. And so we only want to display one balloon at a time. And so this is a perfect opportunity to use a sequential lifetime. We call next, that will terminate any current balloons so that the balloon itself will then hide and disappear. We then get the opportunity, now we've got a new lifetime created, we create a new balloon, we wire everything up, we show it, and we're good to go. So there's a slight complication though with showing balloons. We also need the caller to be able to close the balloon programmatically. So not only do we want it so that when you open a new balloon, we don't want to close the balloon just when you open a new balloon, but we also want to close it when the caller says so. So to do that, we pass through our client lifetime. However, our balloon lifetime is tied to our parent lifetime, our overall lifetime over here. So what we want to do here is create an intersection of the two. So we call create intersection of client lifetime and balloon lifetime. And then from our combined lifetime here, we then add an action to close the balloon and clean everything up. Again, to demonstrate with a diagram, when we call create intersection here, if we have these three lifetimes here, at the point we call create intersection, we've got three lifetimes currently in flight, and what will happen is that the child terminates when the first of any of those lifetimes terminates. So this allows us to make sure that the right balloon is closed. If we then actually look at it in terms of the balloon, here we have our overall lifetime, which is our agent lifetime. Whenever this terminates, everything terminates. This is our overall lifetime. We then have the balloon sequential lifetime. That's our sequential lifetimes object. So if we are trying to say just display the results of some unit tests, so we run some unit tests, we get a little balloon up saying I've run 33 tests, 4 of them have passed and the rest have failed. We want to display those for a certain amount of time. But while that balloon is being displayed, someone hits Alt-Enter, we then have a new lifetime created, and there's an overlap between the two. So what we need to do is create an intersection between our sequential lifetime and our visibility lifetime. And when that terminates, that's when the balloon itself is hidden, and we get that created. So this all sounds very kind of complicated, complex, but all it's doing is it's managing the housekeeping for you. So all you have to do is register callbacks. It does all the cleanups at all the right times because you've said this is the cleanup I want to happen, and here is then the lifetime that I wanted to do. It makes it a bit more declarative, a bit more interesting. Okay, so the important part I wanted to show with this is what I want to talk about with lifetimes. The important thing here is to introduce lifetime and to introduce the fact that you have a lifetime, you can add callbacks to it. These callbacks get called when the lifetime itself terminates. You've got several different ways of creating lifetimes themselves. You can have a sequential lifetime, which allows you to run one action consecutively without overlap. And you've got then intersections between lifetimes as a way of creating a subset of several different lifetimes there. Robert, do we have any questions on lifetimes?
Hi, Matt. Yes, we do. So two that maybe.
Robert?
Yes.
Hi.
Can you hear me?
Yes, sure.
Okay. So two that may be connected. How does lifetime determine the order of object cleanup, and in what order are the lifetime callbacks called?
Yeah. So those are those are definitely the same. So the simple answer is they're called in reverse order. So when you call add action, the items get added to a list, and when the lifetime itself is terminated, that list is then traversed in reverse order, and all the actions are then executed. Okay, so right, we'll move on then. The next thing I want to have a look at is
hello?
is some of the. Oh yes, sorry.
Yeah, there was one more
Hello.
question. Yes. When passing
Yeah, sure.
in a lifetime of IOC, does lifetime cleanup happen on the same thread as the thread that created the object?
Yes, it does. It's a good question. As it stands right now, Resharper will create all objects on the same thread, which is going to be the main thread, the UI thread, and all object cleanup also happens on that UI thread. Yes, and we'll take another look at some threading issues shortly.
Okay, thank you.
Okay, any more? Right. Okay, so I'm going to take a quick look then at how at some more stuff to do with Balloon Manager here. While we're here, we'll take a look at how the balloon notifies the clients that a button has been clicked or an option has been clicked. As you can see here, we create a new window and we just wire up a couple of simple .NET events. Now, .NET events have they're a bit problematic. They are not first-class objects. You can't really do anything with a .NET event other than subscribe to it and unsubscribe to it. You can't pass it around. You can't chain it. You can't manipulate it. You can't do anything really useful with it. So Resharper instead models this idea with what it calls a signal. So what we do in the constructor is we create a signal. We create two signals, one for when the button is clicked and one for when an option is clicked. When the button is clicked, we're going to raise an event of string, and when the balloon option is clicked, we're going to raise an event of object, and the object that gets passed through is dependent on the caller. So if we have a look at our event handlers here, you can see that very simply all we do is we call button click.fire on our signals. And if you look here, these are the definitions of the signals. We've got a signal of string for the button clicked, and then we've got an untyped signal, which is a signal of object for our button click. And in our definition here, again, just to point out, we're using lifetime, so that the signal itself will last for the lifetime. At the end of the lifetime, it will remove all subscriptions and everything is cleaned up nicely. Okay, so a quick look here. We've got the ISignal interface here. It's got a couple of other methods, but the key ones here are advise and fire. Fire is the way to raise an event. You just pass in the event arguments, which can be just any t value, any object you want it to be. It's a generic interface. And advise takes in a lifetime and an action of t value as the handler. So every time the event is raised, the handler is called and the value is passed straight through into that. Again, we're making use of lifetime. So it advises based on the lifetime, adds it to a list based on the lifetime. When the lifetime itself terminates, it gets removed and the subscription is cleaned up and it's all done. The overload with fire with a cookie is not important right now. I meant to remove that one. So let's see what's so ISignal is a strongly typed interface. It allows us to pass events around as objects. It allows us to manipulate them, to do interesting things with them. We can raise events, we can subscribe to it, we can use lifetimes to manage that implementation, and we can do interesting things such as in agent character when we are consuming the button clicked event, we can use an extension method such as flow into, which will allow us to subscribe to the balloon's button clicked event and allow it and flow it straight into a new signal which we create. So the agent character can expose a property which is an ISignal of string, and it will flow it through here. Again, tied to lifetime. When the lifetime terminates, the subscription is cleaned up. So this kind of mechanism, it's really quite similar to what the reactive extensions does. It's perhaps a less unified interface. This is definitely modeling an event rather than RX is slightly more abstract, eye-observable interface, but it's a very similar sort of idea. You subscribe to it, you get values called in, you get a callback, and then you can unsubscribe at a later point. So this now gives us all the information we need to follow how our balloon is displayed. If we have a look at Clippy again, if you click on Clippy, you get a list of options here, a standard list of options. You can select them and implement them, and so on. This is implemented with our click handler here. So this is our agent click handler. What we do is we have our agent object, which is passed through is in the constructor. The component model passes it in as injects it. We've got an agent clicked signal here. It's just a simple signal, which we don't need to worry about what the type is of that. We advise it based on the lifetime. So when the lifetime of the agent click handler terminates, our subscription terminates. Inside, we create a new lifetime definition based on our component lifetime. So again, when the component lifetime terminates, this lifetime will terminate. We get the options that we want to display, which is our list of refactor this, navigate to, go to recent edits, and so on. And then we call agent show balloon. We pass in the lifetime of our newly created child lifetime here. We pass in the string, the options, and our list of buttons. We then have a callback, and we get passed in our balloon lifetime. This is our balloon visibility lifetime. So this lifetime is only valid for the amount of time the balloon itself is visible. At this point, we can now subscribe to our balloon option clicked signals. And again, we use the lifetime we've just been given to say to narrow down the scope of our subscription here. And we pass in a callback for whenever that will get executed whenever the signal is fired. When it does get fired, we terminate our newly created lifetime up here, which because we've passed it through to here, is the parent of our balloon lifetime, and that causes our balloon to hide. And so we now can now cause our balloon to hide when the option is clicked or when the button itself is clicked. Okay, so finally, when we're talking about data flow, it's worth pointing out the iProperty object as well. So we've got ISignal, we've also got iProperty. iProperty is a similar mechanism to Signal. Instead of having a strongly typed event, this is a strongly typed observable property. It has two signals for before change and on change, and it actually has then a value method for getting and setting the value itself. So this allows us to again have a strongly typed object which represents an observable property. Okay, so that's all I want to talk about with data flow. Robert, are we doing okay for questions?
Matt, why not use reactive extensions?
Yep, very good question. Mainly because this was written before RX was. So this has been in the Resharper code base for a good while, and so it was there before RX itself.
Okay, thanks.
Okay.
Seeing we're a little low on time, go ahead and continue. Thanks, Matt.
Right, sure. Okay, so the last thing I want to show then is to do with threading. So we've got, there are a handful of interesting things we need to do with threading. We need to make sure that we run stuff on the UI thread. And we've got the dispatcher class to do that. iThreading is an interface which, again, you can inject into the constructor, and you can do stuff from that. So we've got the dispatcher property, which allows us to run actions on the UI thread. We've got a reentrancy guard, which also allows us to run things on the UI thread, but it'll make sure that there is reentrancy protection. So you can have a guarded context. And if the current context is guard, it will, if the current context is not guarded, it'll run the action immediately. Whereas if the current context is guarded, it will queue it up to run later when the reentrancy guard has finished. We can also throttle events using the grouping events hosts. This allows us to fire incoming events multiple times, and as long as they fit within a particular time span, we will only get one outgoing event. And finally, we've got the timed actions host, which allows us to run an action in a given time span. So quick example of some of those. So if we have a look at the unit test animations, yeah, there we go. So we want to run our animations because they're talking to a COM object. We need to run on the UI thread here, but we get notified of unit test sessions running and that on a different thread, and so we can just call a simple threading dispatcher, begin or invoke, pass in a method. The method here would be agent.play and the name of the animation that we want it to play. While we're here, it's a good example of timed actions. So when we display the notification of how many tests have passed or failed, we don't need the user to actually do anything in response to that. So we want to be able to hide the balloon after a few minutes, after a few seconds. So we have a timed actions, again threading, timed actions queue, again based on the lifetime. That's the action that we want to perform, which is just terminating the balloon lifetime so that we can hide the balloon. That's the time span. So we wait 5 seconds and we terminate the balloon. and then we also get to say how many times we want it to occur, just the once, and then what kind of reentrancy context we want there. We want to say it's guarded, so just have it run on the UI thread, but if something else is happening, wait for that to finish first. Finally then, let's have a quick look at grouped events. That's going to be save animations. So when you save the file, Clippy does a little animation, change into an animation like that. However, you do save all. To save all change documents, you don't want to have lots of animations queued up. So we want to throttle this here. We call threading, create grouping events, throttle everything for 1 second. So no matter how many times the incoming event is fired, as long as it takes within 1 second, just have one event come out, and that's just going to be our save event there. And we subscribe to an event here, undocument saved. The undocument save event calls save event being our grouped event at the top there. We call fire incoming, and again it'll wait 1 second, and no matter how many times fire incoming is called, it will only call play save just the once. So that's a very quick overview of some of the threading issues the threading methods that are available to us. And that's it, actually. That's all I really wanted to talk about. So, Robert, do we have any questions before we wrap up?
Just one more question, Matt. What thread do the timed actions and throttled actions run on?
They get to run on the UI thread, and you get to specify whether what kind of guarded context you want to have. So again, you can say that for reentrancy purposes, you can say this context is guarded. I can't let anybody else run just now. We'll queue it up and it'll run again on the UI thread a little bit later on.
Okay, Matt, that's all the questions that we had. I would like to thank you for the great webinar that you put on for all of us. And the rest of the questions are kind of in depth. I don't think that it's much that we can answer with the time left. So we'll follow up with those people by email. So thank you again, Matt.
Okay, sure. Thanks a lot. Thanks everyone for attending then.